Let's take a look at two more examples and learn how to write the equation of parallel and perpendicular lines. So in example 2, we want to find the equation of the line perpendicular to y equals negative 25x plus 3 that passes through the point 1, 4. So I'm trying to find the equation of a line. I don't know what that equation is, so I'm going to call that line 2. So it's going to be some y equals mx plus b. And I want line 2 to be perpendicular to this equation here. Whoops. This equation there. So let's call this line, I'm going to call this line 1. Okay, what do we know about line 1? We know that, I'm going to write it down here, line 1 has a slope, so I'll call it slope m sub 1, of negative 2, 5. I highly recommend that anytime you're working out problems like this that you write everything down. So write down the slope of L1, and then now write down the slope of the line that is going to be perpendicular. So I'm using this symbol here to show that these two lines are perpendicular to each other. So L1 perpendicular to L2. That's the notation that we use in mathematics. Okay, I want L2 to be perpendicular to L1. So if these two lines are going to be perpendicular to each other, something has to be true about their slopes. So if the slope of L1 is negative 2 over 5, then the slope of L2 has to be the negative reciprocal. So the negative of a negative is positive, and the reciprocal of 2 over 5 is 5 over 2. Now to write the equation, I need the slope, but I also need a point. So notice that we're told that the line that we're trying to write the equation for has to pass through the point 1, 4. So there is our point. And now we're going to use either the slope-intercept formula or the point-slope formula. I'm going to use the point-slope formula just because that's the one that I feel most comfortable using. It's completely up to you. If you want to learn how to write equations using the slope-intercept formula, which is this formula, y equals mx plus b, then go back and watch some of the previous videos. Okay, so now we're going to do all of our substitutions. Y minus, and this is x sub 1, this is y sub 1. So y minus 4 is equal to 5 halves times the quantity x minus 1. Let's distribute that 5 halves to everything inside the parentheses. So that's going to be 5 halves x minus 5 halves. And our last step is to add 4 to each side to get y by itself. So we get 5 halves x minus, and that is going to be 3 over 2. There is our equation that is going to be perpendicular to line 1. Okay, real quickly now, let's take a look at the last example. Here we're asked to find the equation of a line that is parallel. So here we want lines to be parallel. So let's call this line, I'm going to call that L2. And again, I'm going to call this L1. And I want to make L1 parallel to L2. So that's the symbol that we use to show that the lines are parallel to each other. So write down everything that you know. L1, its slope is negative 4. So for L2, if we want these two lines to be perpendicular to each other, what has to be true about the slope of what has to be true about slopes of parallel lines? So M2 must have a slope that is the same as M1. So if M1 is negative 4, M2 is also going to be negative 4. Now we're told that that line that we're trying to write has to go through the point 12, 6. Okay, so again, I'm going to use the point-slope formula to write this equation of this line. Y minus y sub 1 is equal to m times x minus x sub 1. That's x sub 1, this is y sub 1, and then let's just substitute. So y minus, 6 is equal to negative 4 times x minus 12. Now let's distribute that negative 4. So that's negative 4x. A negative times a negative is a positive. So we get 48 on the right, y minus 6 on the left. And then our last step is to add 6 to both sides. Okay, and then we are going to get our equation. And that gives us 50. Oh gosh, I had a brain fart there. Okay, and there we have it.